Okay, so we're still continuing the first lesson of this new unit, Unit 7, which talks about trigonometric equations. On Friday, we talked about two identities, or like 2.5 identities that you will need to know. Okay, so all the identities that we're covering in this section, your basic ones, these are the ones you're going to need to know. After this section, the identities will be given to you. Okay, so we talked about your reciprocal identities, which are basically the reciprocals of each other. So sine theta is equal to reciprocal identity. Sine theta is equal to no. The identity, sine theta is equal to what? 1 over cosecant theta. Okay? And then cotangent theta was equal to?
Cosine over sine.
That is a quotient identity. What about the reciprocal identity?
1 over tangent.
1 over tangent. Okay? You have your quotient identities. Okay? You have your quotient identities. So cotangent theta is equal to what? Cosine theta over sine theta. And then you have your Pythagorean identities. There are 3 of them, but I said all you need to know is the first one. What's the first Pythagorean identity? Yes, that is the most basic one. You can find the other 2 by taking every term and dividing every term by sine squared theta, or dividing every term by cosine squared theta. That's how you get the other 2. Okay? So you need to know those first 2.5, 3 identities. Cofunction identities are the next ones. Okay? As you can see, you have cosine theta sine theta equals cosine of pi over 2 minus theta. Pi over 2 is also could be written how? What is pi over 2? 90 degrees. So it could also be written as cosine of 90 degrees minus theta. It just depends on if you're working with degrees or you're working with radians. Okay, so don't let that throw you off either. It could be radians or it could be degrees. So basically, whatever sine theta is equal to, then cosine of pi over 2 minus theta also equals that value. Okay, and then applies for all the rest of them. Okay, as you see, tangent goes with cotangent, secant with cosecant, cosine with sine, etc., etc. Okay? The last one that you should have at the very top is your even and odd identities. Now, we talked about even and odd one other time before. Even or odd. What does it mean for a function to be even, or what does it mean for a function to be odd? It's a type of symmetry, yes, from the very beginning. Exactly. Odd is the origin, even is the y-axis. So sine of, and remember we figured out it was even or odd by plugging in a negative x. And if we got the exact same thing, it was even. If we got the exact opposite, it was odd. So if you look, you have sine of negative theta equals a negative sine theta. That basically meant that it was an odd function. Because when you plug in a negative x or a negative theta, you get the exact opposite of the original function, which was sine theta. Cosine of negative theta equals a positive cosine theta. That means it's even. It's symmetrical about the y-axis. Tangent of negative theta equals a negative tangent theta. So that means that tangent is even or odd. Which one? It's odd. It's the exact opposite. Cosecant of negative theta equals a negative cosecant theta, which means that cosecant theta is odd. Secant of negative theta equals a positive secant theta, which means that it is even. It is even because it's the exact same as the original. But see, the thing is that secant and cosine go together. So cosine is even, and so is its reciprocal as well. And then cotangent is going to be the same as tangent, meaning that's going to be even or odd. It's going to be odd. And these are basically the 5 identities that you need to know for this particular unit. So we can use these identities to help us evaluate different functions, okay? Now you have your identities listed there in this nice little folder. You can fold it up in the accordion style, pull it out when you need it. we are using pages 28 and 29 for these notes. All the examples are going to be handwritten. We have a total of 15, 16, 17, 18, 19. We have a total of 6 pages of examples. Maybe about 2 on each page. Some of them only have 1, so do plan accordingly so you don't go over to the next page. The first set of examples won't take up much space at all. Maybe 2 lines at the most. Okay? And the same thing with this one. Maybe 2 lines at the most. So, we're given that tangent theta equals 1.28. We have to find cotangent of theta minus power 2. Now that cotangent theta minus power 2 looks very similar to what? What does that look very similar to? This part right here.
Co-function identity.
The cofunction identity, but there's a difference, right? Doesn't the cofunction identity have it written a different order? It's backwards. So what do you think could cause the pi over 2 to be negative and the theta to be positive? A negative, right? A negative. Y'all think graph-wise, I'm thinking straight out. Okay? Cotangent of theta minus pi over 2 is basically the original cofunction identity for cotangent, except with a negative. Okay? If you distribute this negative over, wouldn't that be a negative theta and then a positive pi over 2? Isn't the formula of positive pi over 2 minus theta? Same thing. Same thing. Okay? So, what does cotangent of, when you pull out a negative, okay? This basically is going to end up flipping this to a positive and this to a negative. Is everybody still with me? Okay. Now, cotangent of pi over 2 minus theta equals what? Using the cofunction identity. Look at your identity. It equals what? It equals tangent theta. So I can basically rewrite cotangent of pi over 2 minus theta as tangent of theta, except I just have a negative on the outside because originally the 2 were switched. And then from here, all I can do is just plug in the fact that since tangent theta equals 1.28, I plug that in, and there's my answer. It's supposed to be a negative. Questions?
So, you take that you know that should equal tangent, and you just plug in the tangent and change the sign accordingly.
And the only reason why we changed the signs is because these were switched. Okay? Let's look at the next one. It says if sine x equals negative 0.37, find cosine of x minus pi over 2. Is this written in the same format as that cofunction identity?
Yes.
Yes.
Okay. Let me except instead of a theta, it's a what? It's an x. Does it really matter? No, it doesn't. It just represents our angle. But what did this cofunction identity equal? What did cosine of theta minus pi over 2 equal? It equals sine of x?
Yes.
So that was the identity that you guys wrote down? Wouldn't it be negatives? Wasn't it a positive pi over 2 minus x? Okay. So then take out a negative. That will allow us to switch this to being positive and then the x to be a negative. Is everyone with me? Now, really and truly, you don't have to write down both of these lines. I'm just showing it for the sake of showing it. Now, since you know that this equals this, doesn't sine x already equal a negative 0.37? It would be a positive. And that is your answer. Questions? It's a positive. Because since it was already originally a negative, and it was already a negative on that side, it turns into a positive.
So the pi over 2 just goes
well, this whole part can be replaced with a sign because that's the identity. So instead of writing this whole thing out, we could just replace it with a sign, make it a lot simpler. So we're going to move on from evaluating onto simplifying. Simplifying is a little bit different, okay? Simplifying. If you were ever asked to simplify something, that basically means to get it to its smallest, simplest term, form, okay? Which means that you're going to be taking some big equations, you're basically going to get them down to something a little bit smaller. You might not end up with a number. Sometimes you will, but more than likely you're going to end up with an expression. Okay, you might have like a secant theta or like a 1 minus sine theta or something, okay? But there's different tricks into going about simplifying these things. And it's always important that you remember your rules of when you square something, foiling, things like factoring, things like adding fractions. All these things are going to be good when it comes down to simplifying, okay? So, and you're going to use your identities to simplify these things. So we have cosecant theta times a secant theta minus a cotangent theta, okay? One thing that could actually be a little bit helpful to you when you are simplifying is getting your terms into sines and cosines only, okay? Secant theta is the same thing as saying what?
1
over sine. Using that reciprocal identity, you could rewrite this as 1 over sine. That is a 1. That is a 1. Okay? How else could I rewrite secant theta?
1 over cosine.
1 over cosine theta. How could I rewrite cotangent? 1 over tangent or cosine over sine. Now, if I did tangent, I would have basically sine, cosine, and tangent in a problem, okay? But to make it a little bit easier on myself, you might want to get it into terms of sines and cosines. Okay? Questions up to here?
I thought cotangent is 1 over tangent.
It is, but then if I had that, then I'll have 3 different trig functions versus just working with 2. Yes. Alright, so since I'm multiplying this, I basically can rewrite this as 1 over sine theta cosine theta minus cosine theta over sine theta. Now, these are 2 fractions that are being subtracted from each other. Can I subtract them the way they are? Why not? I need a common denominator. What is my common denominator?
Sine theta cosine theta.
Sine theta cosine theta, okay? So, this denominator has sine theta, cosine theta, we're good. But this one, how do I get it so that it has that common denominator? And I multiply not just the bottom, but also the top. Is everybody still with me? Everybody okay? Something like that. Okay? So now I have a cosine theta squared, or cosine squared theta, all over a sine theta cosine theta.
Hold on. I have a question.
Yes.
From the beginning, can you just multiply by sine theta from where you get that? Like the sine theta, cosine theta minus.
No, you wouldn't be able to do that because it's not an equation. And the only time that you can bring in something like that is if you like dealing with an equation so that you can cancel something out. Okay? Alright, I'm not going to skip this line. I was planning on it, but I'm not going to do it. Sorry, some issues. Alright, now I'm only writing this line for visual purposes, okay? But now that I have the same common denominator, can I write it as 1 fraction?
Yes.
Okay? So this is 1 minus. So really, truly, you could skip this line. Right? Nope, we're not done yet. This is not in simplest form. What equals something?
The top.
The top does equal something. Close. Sine squared. Okay? Now, wanted Chris to know that that was a sine squared theta. Do you remember your Pythagorean identity?
Yeah.
Okay. The one that starts with sine squared theta plus cosine squared theta equals 1. If I subtracted over a cosine theta, which I could do because it is an equation, don't I have 1 minus cosine squared theta? Which means I can replace it with the sine squared theta. That's where that came from. So now I have sine squared theta over cosine theta sine theta. I'm not done yet because I can keep simplifying some more, can't I? I can take out a sine theta because I have 2 up here, but I have 1 down here. So then that leaves me with sine theta over cosine theta, which is indeed.
So this whole time we're just trying to find theta. Oh wow.
Yep, and that's the thing about simplifying. You're trying to get it down to the simplest form. Okay? Now essentially, I didn't need this line right here. Okay, I just did it for the visual purposes. Okay? And to be honest, I kind of didn't need this line either. Okay? I could have jumped straight into this. But I'm just showing all the steps so you guys can have that visual there. But cosecant theta times secant theta minus cotangent theta does simplify down to be tangent theta. Questions? Let's look at another one. We have this one. We have sine squared x times cosine x minus sine pi over 2 minus x. Now you want to try to use some identities before you just start jumping in and trying to change everything in terms of sines and cosines, even though we already have those. Doesn't this look like something, this last part? Cofunction, it is equal to cosine. So right now we have a sine squared x cosine x minus another cosine x. Does everybody see that? This is the cofunction identity. No, we can't cross them out because this cosine is being multiplied to the sine squared x. Now, if there was a plus here, yes, we could have, but there's not. Is there anything else we could do to simplify this? It's not simplified.
Yeah, more.
Would you want to break
Take out cosine.
squared x into
You
cosine?
could do that. You could turn this into 1 minus cosine squared x, but then I heard something else in this area.
You take out cosine.
Don't go with these terms have a cosine in common.
Yeah.
Factor those out.
Factor that's a
You
little
can do
bit.
that.
Yeah, no, for sure.
Now, what Savannah said versus what Nicholas said, we can still get the same answer. There's not one set way to simplify these. Okay?
Why would you put minus 1?
Because when you factor out a cosine from both terms, there's still a placeholder here. So anytime you factor out exactly what they have in common, there's always a placeholder for 1. Another way to check, if I distribute this back in, I need that 1 placeholder to give me that minus cosine x. Okay? Now is this something? Is sine squared x minus 1, isn't that something? Close. Not cosine squared x. Not secant. We did, but it's a little bit different. There's one change. It's not a cosine squared x. It's a negative. And the reason why it's a negative, okay? Again, I'm writing out the original identity, and I'm just doing this for purposes so you guys can see it. In order for this to be a sine squared x minus 1, I have to subtract this one over, and I have to subtract the cosine squared x over. So I have cosine x times a negative cosine squared x.
This time you're multiplying it.
True.
Oh, never mind. It's still there. I thought you were going to so it was cosine. Would that just be negative cosine cubed?
And this will be negative cosine cubed x. Because I I can multiply my cosine.
Yeah, I got lost
After this, did you see how we replaced the sine squared x minus 1 with a negative cosine x squared x? Okay, so we took the Pythagorean identity, which was this, we subtracted over the 1, and then we subtracted over the cosine x. Okay? If I subtract over 1, this equals 0. And then if I subtract over cosine x, that's what I have there. So this thing is the same as this, which means that I can replace the sine squared x minus 1 with a negative cosine squared x, and that's what I did here. And then you can multiply the cosines, and then that just increases your power.
Question about the test?
All right, let's do another simplifying one. Which means here's another one. Here we go. You have negative, that's a negative, cosecant pi over 2 minus x minus tangent squared x secant squared x. Could I use an identity right here, right now? On the very first part, this is a co-function identity, which can be written how? Negative secant x?
Yeah.
Yes. Okay, so that's good. We can replace that cosecant pi over 2 minus x with a secant x.
Tangent.
What about tangent?
Sine over cosine. Good job.
Okay, if I change a tangent into a sine squared x over cosine squared x, should I change the secants as well? I could definitely do that. I could also do something. Does anybody see anything else we can do? We have tangent. Could be tangent squared x could be turned into secant squared x minus 1.
Wouldn't that be negative cosecant and cosecant 40%?
You talking about here? The co-function is the opposite of whatever this is. So secant. You got it right now, right? So anybody see anything else we can do besides turning into sines and cosines and turning tangent squared x into a secant squared x minus 1?
Get back there.
I can factor out a secant. You see, there's 3 different ways you can solve this problem, but you'll still get to the same solution in the end. Now, will one way take you longer than others?
Yes.
Yes, they will. But if you can't recognize which way is going to take the longer way, then do whichever way you can see.
That's what I have.
Okay? I want to start with the easy way first. Okay? And then off video, I want to show you how you can use the other ones. Okay? Question before we go.
Alright, well, I thought it's positive secant on the other side because it's negative cosecant. Like, I thought you have to flip it. So it's positive.
But see, the identity, the way it is, already has the power to first.
Oh.
So the negative just gets brought down, and then this whole part right here
Oh, that makes sense.
is changed into secant. But there's still that negative on the outside. Okay. All right. Now, the easiest way that I see right now is would be to factor out a secant. Okay? I see that as the easiest way. And on top of that, I'm going to factor out a negative secant. Just so that, factor out a negative secant, just so that I can make this first term be a, what? When I take out a negative secant, positive 1. And then when I take a negative secant out of this next term, this
Negative 1.
Positive tangent.
plus
Tangent squared.
plus tangent squared x. I don't know how much longer I'm going to last with this pen, okay? So just kind of stay with me. It's breaking in certain places, okay? That's a tangent. All right? Now this is an identity. Tangent squared x plus 1 equals,
Secant squared.
so I have a negative secant x times a secant
What you just said.
squared x.
So it would be negative secant cubed with that.
Oh, yeah.
in the first part of that, is that a bicycle? Above that? Right?
No, this is a 1 plus.
Oh, one.
That's called stupid thing.
Mm-hmm. Trifling numbers. Alright, what is one way that you guys see that we could tackle this particular problem?
You cross out factor.
Cross out.
Factoring.
Factor, what?
Oh, man.
Cross multiply, yes. Cross multiply sounds really good. Now, I've heard some people say cross out. If you're thinking, hey, I have a sine x here and a sine x here, I can cancel those out. No, you cannot. Because for one, you're adding a 1 to the top sign and you're subtracting a 1 from the bottom sign. Like they go together. You just can't cancel that way. Okay? Yeah, those gets all off canceling out. I can't remember what else I heard. Factoring. Not yet. We might have to factor, but not yet. So let's cross multiply. Everybody remember how to cross multiply? So that's going to be a 1 minus sine x. And then times a 1 plus sine x equals a cosine x times a sine x cosine x. Oh my gosh, yes, it's going to probably simple down to be something so simple like a tangent. Okay? On the left hand side, what are we going to have to do? FOIL. 1 times 1? 1 times sine x? Negative sine x times 1. What happens to those two terms?
Cancel out.
Cancel. I'm not going to write that. Is that okay?
What do you mean?
I'm not going to write those two, the inside term and the outside term. I'm not going to do that in the FOIL.
Oh, yeah.
Because they cancel each other.
Yeah, always cancel each other.
So then 95%.
All right. What? Thank you. Negative sine squared x equals, what am I going to do over here? Distribute. Now, when I distribute that cosine to that sine x cosine x, that's one term. So that turns into a sine x cosine squared x.
Why is it one term instead of? Oh, because the associated formula.
Well, because it's just straight multiplication, it's not an addition where it's going to be like sine x cosine x and then a cosine squared x is one term. Questions up to here? Questions up to here? Alright, this one right here, this is a typo. This one should have been a minus, okay? I'm not going to worry about that right now. Just put a note that says we will revisit this in 2 lessons, in two sections. Okay, we're going to revisit this one. Because it has an equal sign. This is usually related with solving. That should have been a minus, okay? So we're going to bypass that one for right now. Okay. How many more?
Error.
It's not, that was the only one. That was the only one. We're going to rewrite 1 over 1 plus cosine x as an expression that does not involve a fraction. Okay? I.e., we can rewrite that so that it's no longer a fraction. Alright? And you're going to have to use an old concept that we talked about back in Unit 4. Because, we can't apply any identities right now. We really can't. We can't apply a Pythagorean. We can't apply a reciprocal because then that would put a fraction within a fraction. That's too much. But there's an old concept from Unit 4. That's when we were talking about rational root theorem and finding the zeros of real ones as well as imaginary ones. There's something that you're going to have to do to this fraction that involves a word from that particular unit.
Why can't you just call it a 1?
Because that one is being added to the cosine x. And it's kind of like the same thing. We couldn't cancel out those signs because you had something else being added to it. They go together. Not the inverse. It's called the conjugate.
Yeah.
You remember when we had 1 plus I? And you knew automatically that 1 minus I was also root back from Unit 4? These were known as conjugates. To get this so that it's no longer a fraction, you need to multiply the top and the bottom by its conjugate. If you need to put that down somewhere, please do, so you don't forget. The conjugate is the exact opposite of the denominator, so that's going to be 1
Over.
1 over 1 minus.
So that
One
is
minus.
x.
1 minus cosine x. So you're multiplying the top and the bottom by the conjugate. This is going to help you get it so that it's no longer in a fraction.
That was close.
Now when you multiply these, you'll multiply straight across because they're two fractions. 1 times 1 minus cosine x is just what? 1 minus cosine x. But what are we going to have to do on the bottom? When we multiply these two,
Foil.
we're going to have to FOIL, okay? Because we are multiplying 1 plus cosine x by a negative by 1 minus cosine x. So let's FOIL that. 1 times 1,
1.
1 times a negative cosine,
Cosine.
cosine times 1. What happens to the outer and the inner terms? Cancel.
Cosine squared x.
And then you'll have a minus cosine squared x. Okay?
That's the identity.
Isn't this an identity?
That'd be sine squared.
This would be sine squared x because all I'm doing is subtracting over, and I know y'all on that side probably can't see. Starting to see the patterns? I already know what's coming next. Just give me a second. That's still a fraction. Fully aware. It is still fully aware it's a fraction.
Nah,
That's not.
no.
But there's something that you can do now that you couldn't do at the beginning. At the beginning, we had 2 terms in our denominator, correct? Now we only have 1 term. And when you have 1 term in your denominator, you can take the numerator and write it as 2 separate fractions.
Why did it minus?
Because, yeah, the.
Minus.
So whose minus up there?
So the cosine is negative those.
Oh, I see. Wait.
Did everybody see what I just did there?
Yeah, sine squared.
Because remember, when you're subtracting in common denominators, they have to be the exact same. So then that way, it's going to be the same denominator. Again, you can only do this when you have 1 term in the denominator. That's why we couldn't do it from the beginning. Now, what's 1 over a sine squared x?
Cosecant squared.
A cosecant squared x. Right now, we have no more fraction, no more denominator, correct? Okay. But this one, I can't just say this cotangent. Why?
Because there's a square on the square.
There's a square at the bottom. But, oh, don't lose me here. Stay with me. Okay? You can rewrite this. No. Stay with me. You can rewrite this as cosine x over sine x
Minus.
times sine x. Thank you, Luke.
Thank you.
Isn't sine...
You would have tan.
Oh, stop. Wait. Trying to go ahead. I heard someone said that I'm lost. Okay. Everyone, sine x times sine x is sine squared x. Don't you agree?
Yeah.
What's cosine x over sine x? Cotangent. What's left on the top to go with sine?
1.
A 1. What's 1 over sine x? Cosecant.
Oh, yeah.
No more fraction.
Interesting.
So,
Hurt my brain.
Wait, we were